So now we'll start with the local procedure call facility, that is LPC. The LPC passes requests and results between client and server processes within a single machine. So as priorly I was speaking about the same in the same way, LPC passes requests and results between client and server. In particular, it is used to request services from the various 2000 subsystems. When a LPC channel is created, one of the three types of message passing techniques must be specified. The first type is suitable for small messages. The second is suitable for large messages, and the third is suitable for graphical messages. The first type is suitable for small messages up to 256 bytes. Ports message queue is used as intermediate storage, and the message are copied from one process to the other. Second type avoids copying large messages by pointing to a shared memory section object created for the channel. Third method, called quick LPC, was used by graphical display portions of the Windows 32 subsystems. So now this is what is the input output manager of Windows 2000. Actually this much is not in your syllabus, I feel, but is highly required. I should speak about it here. The input output manager is responsible for file systems, cache management, device drivers, network devices. So when I speak about file systems, means everything related to file handling and files. Cache management is nothing but is the cache management, or you can say the information swapping from one while execution, and then swap out after the execution, and this whole process is called caching and caching management. Device drivers, the installation of device drivers, the usage of device drivers, the handling of devices, all is being checked by input output manager. The network drivers and all again are handled by input output manager. So it keeps track of which installable file systems are loaded and manages buffers for input output requests. It works with virtual machine manager to provide virtual memory manager to provide memory mapped file input output. It controls the 2000 cache manager, which handles caching for the entire input output system. So it actually controls the cache manager also. It supports both synchronous and asynchronous operations, provides timeouts for drivers, and has mechanisms for one driver to call another one. So this is what is the input output manager, or you can say the file input output manager, and this is the block diagram which speaks about the same. This is the cache manager, directly related to the file system. File system is also indirectly related to the cache manager through virtual memory manager. So there is a data copy between cache manager and virtual memory manager, and there is a connection between virtual memory manager and file system by a page fault. And then file system is again connected to disk driver and the process. So these all are interrelated things with the input output manager. If we speak about, we skip this all, and if I speak about the file systems, so the file system, this is the topic file system under Windows 2000. The fundamental structure of 2000 file system is NTFS, that is new technology file system, and it is different with compared to FAT or FAT32. The full form of FAT is file location table, and FAT32 implies that the data is saved in the chunks of 32 bits. So this NTFS is mainly prepared for Windows 2000 NT or Windows 2000 with the new technology file system. It is created by 2000 disk administrator utility based on logical disk partition. It may occupy a portion of a disk an entire disk, or span across several disks. So it can have three options. So it can occupy a portion of a disk or an entire disk or span across the several disks, means like there may be several divisions in the disk. All metadata such as information about the volume is stored in a regular file. NTFS uses clusters as the underlying unit of disk allocation. A cluster is a number of disk sectors that is power of 2. The cluster is a number of disk sectors that is a power of 2, that is 2 to the power n kind of thing. Because the cluster size is smaller than for the 16-bit FAT file system, the amount of internal fragmentation is reduced. So here it is 16-bit FAT file system they are speaking. It means the chunks of information is saved in 16-bit format in this slide they are speaking about. So this is the internal layout. NTFS uses logical cluster numbers as disk addresses. This is important thing. It uses logical cluster numbers as disk addresses. A file in NTFS is not a simple byte stream as MS-DOS or Unix. Rather, it is a structured object consisting of attributes. Every file in NTFS is described by one or more records in an array stored in special file called master file table, that is MFT. Each file on an NTFS volume has a unique ID called a file reference. So this is a disk address, that is logical cluster number, and every file has a file reference. 64-bit quantity that consists of a 48-bit file number and a 16-bit sequence number. So this 4-bit file reference is having 48-bit file number and a 16-bit sequence number. Can be used to perform internal consistency checks. The NTFS namespace is organized by a hierarchy of directories. The index root contains the top level of the B tree. So under file system there is a topic recovery. All the file system data structures updates are performed inside the transactions. Before a data structure is altered, the transaction writes a log record that contains redo and undo information. So on the basis of this log record, we can recover the information from wherever we find a problem into the process. After the data structure has been changed, a commit record is written to the log to signify that transaction succeeded. After the data structure has been changed, or you can say after the transaction has been done and executed, a commit record is written to the log file. After a crash, the file system data structures can be restored to a consistent state by processing the logical records. This scheme does not guarantee that all user file data can be recovered after a crash, just that the file system data structures are undamaged and reflect some consistent state prior to the crash. So basically, similarly, as there was a recovery management I have spoken about, like checkpointing is one of them, log recovery mechanism is one of them, forward and backward recovery management is again a different kind. So there are certain others are there, but this log based recovery does not guarantee that you will completely recover after a crash. The log is stored in the third metadata file at the beginning of the volume. The logging functionality is provided by the Windows 2000 log file service. The security under the file system. So each file object has a security descriptor attribute stored in the master file table record. The attribute contains the access token of the owner of the file and an access control list that states the access privileges that are granted to each user that has access to the file. Windows 2000 supports both peer-to-peer and client-server networking. It also has facilities for network management. It was mainly more important in network management when it came. To describe networking in Windows 2000, we refer to two of the internal networking interfaces. One is NDIS and second is TDI. So these are the two network interfaces. The first one is called Network Device Interface Specification. It separates network adapters from the transport protocol so that either can be changed without affecting the other. TDI, that is Transport Driver Interface. So this is Network Device Interface Specification and this is Transport Driver Interface. It enables any session layer component to use any available transport mechanism. Windows 2000 implements transport protocols as drivers that can be loaded and unloaded from the system dynamically. So now networking protocols. The server message block, that is SMB protocol, is used to send input output requests over the network. It has four message types. First is session control, second is file, third is printer, fourth is message. The network basic input output system, that is BIOS, is a hardware abstraction interface for networks. It is used to establish logical names on the network, establish logical connections of sessions between two logical names on the network. It supports reliable data transfer for a session via NetBIOS request or SMB, that is server message blocks. So net basic input output system network extended user interface, that is NetBEUI, default protocol for Windows 95 peer networking and Windows 4 work groups, used when 2000 wants to share resources with these networks. So Windows 2000 uses the TCP/IP Internet Protocol to connect to a wide variety of operating systems and hardware platforms. So it uses the existing TCP/IP Internet protocols. PPTP, that is point-to-point tunneling protocol. Tunneling protocol actually is a dedicated protocol between one network, one computer to the other computer via remote access. Is used to communicate between remote access server modules running on 2000 machines that are connected over the internet. So process management process started via create process routine, which loads any dynamic link libraries that are used by the process and creates a primary thread. Additional threads can be created by create thread function, that is under create process. Every dynamic link library or executable file that is loaded into the address space of a process is identified by an instance handler or handle. Process management again continued. Scheduling in Win32 utilizes 4 priority classes, that is idle priority classes, normal priority classes, high priority classes, real-time priority classes. To provide performance levels needed for interactive programs, 2000 has a special scheduling rule for processes in the normal priority class. Windows 2000 distinguish between the foreground process that is currently selected on the screen and background processes that are not currently selected. So foreground currently selected, background not currently selected. This is the two way it distinguishes between the processes. When a process moves into the foreground that is currently selected on the screen, Windows 2000 increases the scheduling quantum by some factor, typically that is 3. The kernel dynamically adjusts the priority of a thread depending on whether it is input-output bound or CPU bound. To synchronize the concurrent access to shared objects by thread, the kernel provides synchronization objects such as semaphores and mutual exclusions or mutex. So as we know, in synchronization we have studied that there is actually in deadlocks also we have studied. When we were speaking about deadlocks, there were four necessary and essential conditions, in which one of them was mutual exclusion. And semaphores are similarly to solve the critical section problem. So to synchronize the concurrent access to shared objects by threads, the kernel provides synchronization objects such as semaphores and mutex. Again, the same concepts are being used in this way. Okay, now inter-process communication. Win32 applications can have inter-process communication by sharing kernel objects. An alternate means of inter-process communications is message passing, which is particularly popular for Windows graphical user interfaces and applications. One thread sends a message to another thread or to a window. A thread can also send data with a message. This is how we know it is at inter-process communication. This is more reliable than the shared input queue of 16-bit Windows because with separate queues, one stuck application cannot block input to the other applications. The Win32 environment is a region of reserved address space because functions that rely on global or static data type typically fail to work properly in a multi-threaded environment. The thread local storage mechanism allocates global storage on a per thread basis. So there is a global storage mechanism on a per thread basis. This is how the memory management is being done. The mechanism provides both dynamic and static method of creating thread local storage.